graph representation. We can represent the graph in two ways. One is adjacency matrix. How? We'll see here. Suppose we have graph like this, 1, 2, 3 and 4. We have graph like this. So how we make adjacency matrix of this? Because 4 vertex are there, so we'll write like this. 4 rows and 4 columns. So 1, 2, 3, 4, 1, 2, 3, 4 rows and column. So how we'll write here? We'll see here. So first we don't have any edges from first to first, so we'll write here 0. But we have one vertex from 2 to 1, so we'll write 1. We will have one vertex from 3 to 1, so we'll write 1. We don't have any vertex from 4 to 1, so we'll write 0 here. The same way, from 1 to 2 we have one vertex, so we'll write 1. Sorry, one edges, we write 1. And from 2 to 2 we don't have any, so we'll write 0. From 3 to 2 we have one edges, so we'll write 1. From 4 to 2 we have one edges, so we'll write 1 here. Now in respect of 3, we have vertex from 1 to 3, so we'll write 1 here. From 2 to 3 we have one vertex, so we'll write here 1. 3 to 3 there is no vertex, so no edges, sorry. And 4 to 3 we have one edges here. Now for the 4 to 1 there is no edge, so we'll write 0. 2 to 4 we have 1, 3 to 4 we have 1, and 4 to 4 we have 0. So this is adjacency matrix. Or we can say in respect of if we talk about another one, suppose we have like this 1, 2, 3, 4. We have graph like this. So if we have graph like this, so the adjacency matrix will be like this. There is no edges link between the vertex, so all will be 0 in respect of first, second, third, fourth column. In respect of 1, 2, 3, 4 rows, all will be 0 because there is no connectivity of edges. So this will be the adjacency matrix. Now second way of representation is adjacency list. Adjacency list. So how it will work, we'll see. For first one, for this, how we'll make it. So there are 4 vertex, so for individual vertex we'll write 1, 2, 3, 4. We'll make like this. And from one vertex second is connected, so we'll write 2 here. And this is for pointer for the next one, next node or next vertex we can say. And from 1 to 3 is also there. From 1 to 3 is also there. So next one is 3. Only 2 edges are there which are connected with the first vertex, so 2 nodes are there. Now for the second one, how many connectivity are there? There are 3 edges. One is connected to 1, one is connected to 3, and one is connected to the 4. So we'll start from 3. We can start from anywhere. We'll start from 3. So we'll write 3 here. Now next one will be 4. The next one is 1. The last one will be blank. Sorry, here this will not come. last one will be blank because this is last, null. Now in respect of 3, again there are 3 edges are connected with the 3. So 3 nodes will be there, or 3 vertex will be there. 4, 2, 1. So we start from 1, 1, 2, next one is 4. This is end one, so we'll write here cross. In respect of 4, we have only 2 edges. So one is 3, one is 2. So first we write 2, then we write 3. So this is called adjacency list. This is called adjacency matrix. This is called adjacency list. So in respect of this graph, how we will make this graph? We'll write 1, 2, 3, 4 like this, and because all are not connected, so we'll write simply null. Null, 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 and null. So this is vertex. These are vertex, but there is no edges because this is null graph. So we can say 0 order of 0. So we can say simply order of V, order of vertex only. So, and here space required, we can say for space required for this adjacency list, number of vertex into number of vertex. So we can say order of V square for adjacency list. And for adjacency matrix, this is for adjacency list. For adjacency matrix, the space required is equal to vertex plus 2e, or we can say vertex plus edges, or we can say order of vertex plus edges. Here vertex and edges both. So we can say best case will be order of V, and worst case will be order of V square in respect of this. This is for we can say when more edges are there, or we can say dense graph. And this is when less edges are present. This is better for less edges, and this is better for more edges. So this is all about the graph representation.